Welcome to our first video in our equations unit. This one is on solving addition and subtraction equations. So you should be filling this in the next page in your note packet. You've got your title up top. Make sure to put your name, your date, your class period up top, and then your essential question, 6E5, how do I find the solution to an equation? Pause it, fill it in, and then let's go.
Okay, the second thing you need to do is to go ahead and write your question on the left-hand side of your Avid paper. Why do I need to do the same thing on both sides of the equal sign? And we're going to hopefully be able to answer that question after the video.
So all of this practice and all these notes are going to go on the right-hand side in the big open section. We're going to start with our first piece, the subtraction property of equality. It says if you subtract the same thing from each side of an equation, the two sides remain equal. So that's going to be the key to solving equations today. Let's start by modeling it so we have a picture, and that helps us see why we're going to take that next step. So we practiced this yesterday, w plus 2, so we have some amount w, and then we're going to add on 2, so they're connected right next to each other. W and 2 combined is equal to, sorry, I drew this much better in class yesterday.
And it doesn't matter if
7.
the total 7 goes on the bottom or the top, you just need a
as long as they're
total.
both the same length in size. But now if you look at your picture, if we said, well, how do I find out how much this W is? Look at your picture. 7 is the whole thing. If we get rid of the 2, we'll be left with our W. That's what we want to do in our equation. Always draw a line down through the equal sign because we want to do the same thing on both sides of our equation. Have to keep it balanced. And all we want to do is get rid of the 2. They added it, so we're going to subtract it away. But we have to treat both sides of the equation equally, meaning we got to do that on both sides. I had 2, but I got rid of it, so that cancels out. It turns into a 0, and all we're left with is W. We kind of got W by itself. 7 minus 2 is 5, and it's as simple as that. We did the opposite of our addition. We subtracted, just like our picture showed us, and we found our answer. But you have to show all of that work in solving an equation. And then you always have to do your check. That means take your answer, 5, plug it back in to the original equation. So instead of W, plug in 5, plus 2. 5 plus 2 is 7. That's what we wanted. So we have checked our solution.
And this check seems pretty simple. Go ahead. With these, but when we start adding decimals and fractions, we're really going to need our check. Okay, next two examples, we've got y plus 8 is equal to 15 that you need to write down. And then go ahead and draw your line and make two sides of the equation. We're going to undo that 8 by subtracting 8. Whatever we do to the left side, we've got to do to the right side. And now comes the time where we're going to simplify. 8 plus 8 minus 8 is going to go ahead and give us a 0 and cancel each other out. 15 minus 8 is going to be 7. So time to simplify by bringing down that y. 15 minus 8 is 7. And now we got to check our work. You want a different color, don't you? Christmas colors. You're putting the 7 back in for that y in the equation. So you're going to add up with 7 plus 8 is equal to the right side of 15, the way we wanted it, so we are done.
So think of it as you're solving an equation, you're always doing the opposite. They had added 8, so Mrs. King subtracted it away to get rid of it. Wow, that's an awesome line.
Thanks. Next problem includes a decimal, so we got to make sure that we're lining our decimal places up. This is 3.5 plus m is equal to 12.7. Some of us get stuck when we have a 3.5 here because we don't have a sign in front of it. It still is positive 3.5, so to undo that 3.5, we're going to still continue to subtract 3.5 from both sides.
So notice we're always doing the opposite of whatever they did to the variable. If they added something, we're choosing to subtract to make it go away.
3.5 minus 3.5 is going to give us a 0. We're left with m is equal to, sorry, that's just
9.2.
I thought we were going to have to borrow and show some fancy work, so I left myself room.
They'll need to borrow and show all their work.
They don't have to borrow in this case, but it's okay. M is equal to 9.2. So we are checking our work by putting our answer of 9.2 back into the equation. So we're showing 3.5 plus 9.2 is going to be equal to 12.7. And we do need to show our work, making sure that we're lining up the decimal point in our check and not just writing the sentence just to write the sentence. And it does check out.
So make sure you show how you actually did each one of those problems and checked with all of your work. So now we're going to jump to the next part. Here's our next question over on the left. Make sure to kind of space things out in your notes. Don't cram it all together, but leave a little space. And then our next question is, what are inverse operations? And you'll learn a little more of that as the video goes on.
And another definition in the right-hand side of your notes. So skip some space from the top part because we're now moving into the addition property of equality. And that states if you add the same thing to each side of an equation, the two sides are going to remain equal. So once you have that written down, go ahead and write the sample problem down. 2 is equal to e minus 5. And on the right-hand side, we're going to draw ourselves a bar diagram. So he's starting off by writing an e, because that's a total amount that we're starting with, some number e. And then we're going to go ahead and subtract 5 from that e. When we subtract the 5, our answer is going to go ahead and give us 2. What are you doing, fancy colors?
Just so they can see the two different parts.
Sure, so the two different parts, that's 2 by the way. The two different parts are going to add up. They need to be the same size as our e in our bar diagram. And then we're going to go ahead and solve it to just prove what our model bar diagram is showing us. And we're going to add 5 to both sides because a negative 5 plus 5 should give us a balance of 0. And that's what we need on the variable side to get rid of e. You need to cancel the negative 5 plus 5 out so that e stands by itself. So e is going to be equal to 7. Whatever you do to the right side, you do to the left side.
And you have to show us that. Don't fight us on it. You won't win. You have to show that every single time.
So you're going to check your answer. Oh, he's not even changing colors. 7 is going back in for E.
I'll do Christmas colors just to make you mad.
7 minus 5 is 2, so it does check out with the original problem.
Okay, so let's see a couple of those in action here. So our inverse operations, that's how we decide how we're going to solve an equation, is we always do the opposite. We use the inverse or the opposite to undo the problem.
You're trying to get that cancel out of 0 for adding and subtracting so that the variable stands by itself.
Now, you're going to get used to always looking on the left side, but don't just look there. Always look at where is the variable, what did they do to the variable. In this case, they subtracted away 6.3. So to undo that, I want to do the opposite. I want to add back that 6.3. But I have to do that on both sides in order to keep the equation balanced. Subtracting 6.3 and adding 6.3 cancel each other out. They go back to being 0. And all you're left with is your z. 2.1 plus 6.3 is 8.4 for an answer. And then we go back and do our check. I'll make sure I switch colors. In place of z, we put our answer, 8.4 minus 6.3. So anytime you're dealing with decimals or fractions, we want to see the work to support it. Show us that you really do get 2.1 as an answer, and then you're allowed to put your check. Same thing with your fractions. Don't get thrown off just because it's a fraction. They subtracted, so you use your inverse, meaning you're going to add 3/8 to both sides.
Minus 3/8 plus 3/8 cancel each other out. You're left with h on the left. 1/8 plus 3/8 is 4/8, but Mr. McKenzie knows better to go ahead and reduce to 1/2.
Now, with fractions, when you go to do your check, use the unreduced version of it, because we're going to want something that already has common denominators. So h is equal to 4/8, so I plug that back in for h. 4/8 minus 3/8. We have common denominators, so we can go ahead and subtract, and we get 1/8, so we have checked our solution.
Moving on.
But you have to show all of that work and your check for every single equation that you do.
You want this written down, right?
Yeah, so pause for a second, write down the whole problem, and then hit play, and we'll talk you through how to solve it.
All right, so Zach gave 5 trading cards to his sister. Now he has 41 trading cards. Write and solve a subtraction equation to find out how many cards Zach had originally. So I know we need a minus sign. I know we either need a Z or a C.
So let's call it Z for Zach. How many did he start with?
Okay, he gave 5 to his sister, so he subtracted 5 from his original amount because he gave them to his sister, and now it results in 41. So z minus 5 is 41 is our equation. We're going to go ahead and undo that with the inverse operation. The opposite of subtracting 5 would be adding 5 to both sides.
So think if he got those 5 cards back from his sister to put them back where he started.
Z would be equal to 46, and we now have to check his solution. Does it make sense for Zach to have 46 cards? He gave 5 of them to his sister, and now he has 41. And it sure does make sense, so we're good.
Some of you probably thought, oh, I just add 5 and 41 together. Yes, that's how you're going to solve the equation, but you have to write the original problem first as an equation before you get carried away with trying to solve it. Pause again, write down the whole problem, then hit play, and then we'll solve it. This one says it takes 43 facial muscles to frown. Mrs. King is frowning right now. This is 26 more muscles than it takes to smile.
They're frowning because it's too long.
I know. So think about what don't we know. We don't know how many muscles it takes to smile. So we're going to say S for smile.
It's an addition equation, so
It
plus.
says 26 more than. More than means to add. So plus 26 is equal to the number of muscles that you need to frown. Once you have your equation, now you show your work on how to solve it. Remember, you're always undoing it. They added 26, so we want to get rid of that 26. Those two cancel out. They turn into a 0, so we're just left with S.
You're going to need to borrow, which means in your check you have to carry, just so you know.
And we get S is equal to 17, so it takes 17 muscles to smile. We go to do our check. Original check is S plus 26, so we put in our 17 plus 26. Anytime there's any borrowing or carrying, you have to show that work in order to get credit for your check. But we do
check's
get,
not a check unless you show work. Thanks.
as long as you do your check, you are good.
We'll see you tomorrow.